everyone, we are here at Enlit Bilbao, and at Advantech booth we also have ABB with a live demonstration of software-defined electrification. We are going to hear a little bit about this live demonstration and also about our partnership with ABB and Red Hat. So first of all, I would like to introduce Christopher Hausmann from ABB. Can you walk us through a little bit about this use case?
Yeah, thanks, Andy. This use case is about a mine operation. In the current mine operations, we face a situation where we have weak electricity provisioning from the grid. So mine operators start using local energy productions, whether it's renewable energy or diesel gensets, to produce some of the energy, the electrical power they need to operate their mines locally. And this brings additional challenges for the grid they are operating. The connection of the local grid inside the mine to the remote grid, the external grid, is quite weak. But the grid inside the mine needs to be stable to provide all the big and small consumers inside the mine with the electrical power they need to ensure continuous mine operations. In this example, we show how we address the issues that mine operators face currently with their electrical power supply with a new concept that we have, where we virtualize and containerize our hardware for protection, control, supervision and optimizing of the mine operations, and bring all in one box. And Tony can maybe introduce you a bit about the hardware.
Yeah, so very interesting, Christopher, thank you for that. And you've been talking a little bit about a utility in a box, and you talked about the utility part. Maybe now we can look at the box and see what that means as well. From that point of view of Advantech, we are a supplier of industrial computers, the largest in the world. And here we have a typical substation computer, which is really designed for use in these very rugged and robust environments. So for a utility that needs this kind of equipment, we have some basic functions like redundant power supplies, redundant storage, and a very robust operating environment which we can support. As well as the redundancy and the robustness on the hardware side, we can also support redundancy at the application level by supporting various kinds of redundant features there. In order to explain redundancy and the way in which we manage that through virtualization and orchestration, I'd like to invite my friend Daniel here from Red Hat to explain that. Thank you, Dan.
Yeah, thank you, Tony. So we at Red Hat are a 100% open source company, and we are known for our enterprise Linux operating system in the data center world, and we're now expanding also into the grid. And this is a great example for us certifying the Advantech hardware specifically for this type of workload, and running different types of workload from ABB in different formats on the same box. So we're enabling virtual machines, we're enabling container technology, all running on that same box. And what's specifically interesting is that we're not just orchestrating the resources, but also for real-time application. So we have the virtualized protection, which has very peculiar requirements around low latency, no jitter. So it has to be very deterministic performance, running side by side with supervision systems, SCADA systems that require maybe a little bit less. And we can run these systems of mixed criticality on the same box, side by side, ensuring that all get the resources they need and work in a box together.
Thank you, Daniel. So in a utility in a box, we're talking about a box that's hardware. We're also talking about a layer of middleware that manages all of the different resources that are used here. And then we have a range of applications, which in this case from ABB include everything from the control of the generation, the power generation, through the system of control and supervision, protection against any kind of dangers that may occur, and an overall supervision of the system. So we have a complete utility that's available, deliverable in the box. In this case, we have one computer here, but in a fully redundant system, we would have a cluster of 3 units, and that would provide the high availability to guarantee full delivery of electricity supply in a complicated and sometimes rugged environment. So thank you to Red Hat and ABB for this opportunity to work together. Thank you.